Hello, everyone. My name is Karthik Vijay Raghavan. I'm a DocumentDB specialist. As say, I've been hosting this Twitch show, DocumentDB Insider Hour, for the last few months here. Again, this is our 14th episode, and I'm super excited to be here. We have an amazing guest joining us today. But before I introduce our guest, let me introduce my co-host, Cody Allen. Cody, can you say
Oh man, I got so excited. I was like, man, this is a great intro. I'm a great guest. You're excited. But I'm just the co-host. But I agree. We do have an awesome guest joining us today. Hi, everyone. Cody Allen, AWS Solution Architect here. Happy to be here. Thanks for inviting me back, Karthik.
Awesome. Great to have you on the show, Cody. All right, now let's jump to our guest. Our guest is from Hackalade. He's a CTO at Hackalade. That's it. Let
Cool
me
deal.
bring him online here. Pascal, great to have you on show.
Hello. Happy to be on the show. Very excited.
Awesome. So, folks that are listening to us here in the Twitch show, again, like I said, this is our 14th episode, and today we have a very, very interesting topic. This is something that I'm very passionate about, just document modeling. I've been building applications for various customers, from relational to non-relational databases, and I've been doing this for 16 years now. And I've been predominantly all my time has been in the middle tier and the database. So data modeling is something that I have done day in and day out, and I know what good modeling looks like, and I very well know what not so good modeling looks like. So and especially when it comes to document databases, there are a lot of myths and assumptions about it. So I'm super excited to have Pascal, who has built a company around this to basically help customers ease the process of document modeling. So Pascal is going to be announcing some key milestone releases that Hackalade has made recently. I don't want to steal his thunder. So without further ado, Pascal, I'll give the stage to you to talk about Hackalade.
Thank you so much, Karthik. I've got a little presentation today with an overview, and then we'll go into a demo and some Q&A. I think that everyone can post questions in the chat, and the co-hosts will be reading them and synthesizing, so we can have an interesting session for you today. So the big announcement today is that we are now supporting Amazon DocumentDB as part of all the technologies that our tool for data modeling has been supporting. So as you can see, there's Amazon DocumentDB over here. We also support Neptune, DynamoDB, Redshift, EventBridge, Schema Registry, Glue Data Catalog, and also S3, where you could store Avro schema, JSON schema, Parquet, and as well RDS for relational databases. Basically, our tool for data modeling supports all kinds of technologies for data at rest, but not only, also data in motion with REST APIs, Avro for Kafka, etc., etc. So schemas are everywhere, and we have the focus to support all of these modern technologies that you find in your ecosystem. So what do we mean with data modeling? We simply mean the ability to have a picture that represents an entity relationship diagram of the different documents in your collections. So as such, it sounds similar to the traditional tools that you may have used in relational databases like Irwin, ER Studio, Power Designer, IBM InfoSphere, etc. But there's a big difference. And the difference is that our tool was built from the ground up to support and handle the nested structures that you find in JSON. And so our entity relationship diagram looks different than with these traditional tools, because you can see hierarchies and also polymorphism, etc. And so we'll go through the details of that. But hold on. You probably think, well, we're in an era of agile development, and DocumentDB is a schemaless database. And in addition to that, JSON looks so easy. So why should we do data modeling when it comes to DocumentDB? And it comes to technical debt and doing things right. You probably don't need to do rigorous data modeling if you have a really simple application that is the only one that reads and writes the data that you're storing in DocumentDB. But if you have a complex mission critical application that's part of a large organization with many business users who will need to query the data, if you need to feed machine learning and artificial intelligence, etc., there's a necessity for everyone to understand the context and meaning of the data. And you also want to make sure that your application has the right schema so it will continue to perform as it evolves and scales. So I'm not, you shouldn't just take my word for it. Gardner Group has talked about this subject, and it's also called schema on read. And they say that it doesn't mean that you don't have to think about schemas during the design phase, or that schemas should be done by amateurs. And so there's best practices and there's literature on this. Martin Kleppmann, who I think worked for LinkedIn, wrote a fantastic book on designing data-intensive applications. The chapter number 2 of the book is about data models and schemas and how important they are in the development of a quality software. So basically, when you think about data modeling with DocumentDB, you're going to take a different approach than what you might have done if you come from the relational database world. With document databases, you have this wonderful concept of JSON documents that are very flexible, very powerful, but you are going to want to first design the application with all of its workflows and screens, and you're going to derive the data model from that. And in an agile way, you will iterate through the development of the application and the improvement and evolution of the data model. So it's a mind shift. And it's really important to understand that many of the things and habits that we have had in the relational world need to be unlearned in order to properly design for DocumentDB. Instead of having an application agnostic, normalized relational model, we need to think in application specific manner, derive the access patterns and queries, which will in turn define the data model, which will in turn define how you store the data. In other words, for example, instead of doing joins when you read the data in relational databases, what you're going to do is join the data at the time you write to the database. So when the data is retrieved, it can be retrieved in a very performant and effective manner for the performance of your application. So there's lots of benefits of data modeling from the perspective of the users, because they're going to receive an application that it more closely matches their expectations. From a management point of view, because it reduces the risks of adopting these new technologies like document databases, and it's going to make people productive and efficient. And from a developer's perspective, because the collaboration with the different stakeholders to understand how data needs to be denormalized to satisfy the needs of the application, all of that will bring clearer requirements, less frustrating rework, and better performance of the application. So it's a win-win-win situation to do data modeling, and it's a best practice that has been used by people who have successfully migrated from relational to NoSQL databases.
Pascal, I have
Yeah,
a quick question.
sure.
This is a foreign concept, right? For a lot of folks that are coming in as a relational database DBA or dealing with relational models, is the thought has always been, yeah, with relational database, I do the data, then the data modeling, and then the application reads that. But the big pushing point to go to something like a NoSQL data model is I don't have to worry about it anymore. But what we're seeing here is you do, right? It's not that you can just completely forget about it, move on, and just leave it up. I like how you put data amateurs. Don't just leave it up to the data amateurs to decide this. You still need to think about that. So I want to really hone in on that, because that it seems like we're talking two disparate topics here. You don't have to worry about data modeling, but you do. So there's a balance there, it sounds like.
Yeah, so it's definitely a balance. I would go further than that. Within the relational world, there were guardrails. There are rules of normalization that pretty much tell you how you can do things step by step to achieve a good data model. Of course, there's still on the relational side ways to have poor data models, but there are guardrails. With JSON, there are no guardrails. You can do anything you want. You can design a huge document with lots of levels of nesting, which may seem good from your perspective, but then as your data volume and loads increase, may lead to things like unbounded arrays and documents that keep on growing, that will result in poor performance down the road. And so there's no warning signs of that. And what a tool will provide is the ability to visualize some of these things and to have a discussion with the different stakeholders of the application, the business owners, the architects, the developers, the DBAs, maybe, to have a discussion on different what if scenarios. What if we have the data volume increases so much that the cardinality of relationships becomes unbalanced? Aren't we going to have a choking point? The ability to have this discussion around a picture, around an entity relationship diagram, allows to go through these different scenarios without having to write a line of code. And that's a very productive way of developing applications that will save huge amounts of just pure cost, but also frustration when you build a complex application.
I think your image sums it up perfectly, right? We're not doing anything different than you've already done. We're just doing it in a slightly different order here. Yeah.
That's correct. But I remember that when I created this tool, it was out of my personal need, because all of the developers that I worked with were coming from the relational world. And even though they were half my age, they still had this reflex of normalizing because it was more efficient or it looked better. And I kept on saying, no, we've got this screen that for which we need to retrieve all of the information in just one seek, one query, and return all of it in an instantaneous manner. And in order to do this, we need to denormalize when we write the information. And in order to have that conversation, it was much easier to do it with a picture, an entity relationship diagram, than doing it with a JSON sample document or with code.
Our minds aren't structured to be unstructured. We need images and visualizations. But that's all,
Exactly.
that's it. The best tools come out of necessity.
Yep. So another thing that I want to point out is that databases, a database is never an island. It's part of an ecosystem. And let's say your DocumentDB is the master transactional database. Inevitably, in a large company, but not even, you're going to want to export some of those transactions to S3 objects, for example. And then it's going to be sucked up in 3 different stages of a data lake, and it might be streamed to a data warehouse or to artificial intelligence and machine learning. And what you want to make sure of is that your schema is consistent across these different technologies, and that when it evolves, that you can easily synchronize this evolution along the way in the entire chain end to end. And so data modeling is not just for the purpose of your DocumentDB store. It's also it needs to be put in the context of the entire data pipeline. That's one aspect. And the second aspect is, while this right-hand side, the technical side of converting a data model into a schema that can be consumed, can be a consumable contract for the technology, it also needs to be published to the business side, enriched with context and meaning, so the users understand how to query the information and what is the meaning of the data when they do these queries, so they can make intelligent decisions with this data. So no database is an island, and therefore everything needs to be thought through. So now I'm ready to go into the demo, unless you have some questions. And I'm going to talk about a few use cases. The tool is actually very simple. It's not some Swiss Army knife that will solve all kinds of problems. There's the base problem is starting a model from scratch and forward engineering this to the database. Conversely, there's the ability to reverse engineer an existing instance to discover its structure and document it, or to make sure that what's in production corresponds to a baseline that is maintained by the governance department. I'm also going to briefly show how we can do model-driven API generation, where we can generate REST APIs out of a DocumentDB model of collections. We'll quickly go through a migration from RDBMS and show how we can help denormalize a relational model into something that will better fit the document model of DocumentDB. And we'll talk about briefly how we can help with some aspects of data governance and regulatory compliance. So let me switch to the tool. So Accolade is a downloadable client. It is not a SaaS offering. A SaaS offering is in the works, but currently it's a downloadable client, which has the advantage of one, running under Windows, Mac, or Linux. But also, since it's a client, that means that when you connect to a database and do reverse engineering, there's absolutely no data that comes out of your network. We don't have any telemetry. We don't collect anything, and everything remains proprietary and confidential inside your network. As I mentioned earlier, we support a whole bunch of technologies. I have all of the plugins loaded on my machine, and so you see many icons, but you probably will only have a handful of them at a time. And when you create a model, you typically have to choose which target technology you're going to be working with, because all of these things are vastly different. If we take a Neptune database or a Redshift or DocumentDB or DynamoDB, the terminology is different, the storage model is different, the indexing is different, the data types are different, etc., etc. And each of our plugin has been developed specifically to handle the characteristics of the target technology. So you have a blank page to start. And from here, you'll see on the left-hand side an object browser, on the right-hand side a properties pane, and you do your work in the middle pane, the central pane, where either with a right-click and a contextual menu, or through toolbar icons or menu options, you can start building your model. So I'm not going to type up very much, but let's say we start here with a new collection. We're going to have the key is going to be _ID with the data type object ID. And by the way, this gives me the opportunity to show that all of the data types defined for DocumentDB are listed here, and they're specifically for this target. We can start adding additional fields. We can make them, for example, an object here and start building nested structures, and we can go as deep as we want and start building these things. This can be done in the entity relationship diagram, or there's a convenient tree view where things can be added as well. One collection at a time, where you can build the structure from this view. You will be able to view a JSON schema specification of what's being built. We support all of the published specifications of JSON schema, and the tool was built on JSON schema, and we persist the models in JSON. So this is completely open. We can, for example, since we're maybe in a environment with strong data governance, we want to, for example, import information, import structures that have already been defined elsewhere. So I'm going to choose here a structure, let's say over here, that's been defined for a party. And within that structure, I'm going to choose the object for a person, and I'm going to import that. So you see that without typing, I've been able to leverage an object that's been defined previously and maybe is used throughout the company, etc. We can continue to build the model by importing or referencing from different sources. I've just shown doing it from a JSON schema. It can be inferred from a JSON document. We can import DDLs, XSD, Excel, etc. So I'm also going to show how you can add more collections. And for the sake of documentation, we can build relationships. Now, we understand that this is a non-relational database and that foreign key relationships are not enforced by the database, yet it may be useful to have relationships in the data documented to better understand the model and the context and the meaning. So I'm not going to type too much. I've actually prepared a data model that looks a little better, has lots of structure and information, different collections. And once you've built your model, as I mentioned earlier, you can have conversations with different stakeholders. You can do what-if scenarios. How do I denormalize this and that to best support the access patterns of the application? And once you've built it, maybe you want to test this whole thing. So we have generated on the fly the scripts that will create the database, create the collections, and also created a sample document that can be committed to the database. So if I go here and apply to instance, I've created a connection to the DocumentDB instance with the host cluster endpoint, authentication, SSL certificate, and in my case, I don't have a VPC integrated with this instance, and so I go through SSH on an EC2 instance that I've set up with my AWS access information. I have Studio 3T, the GUI, running and connected to this database. And I'm just going to apply this script, this database collection script and document to Studio 3T. So if I refresh here, this database has been created. The collections that I had in my model have been created. I forgot to show that we have for these collections, I had created some indexes, and all of that got forward engineered to the instance. And we have all of the information. Of course, I created only one document, but it was also forward engineered to the database. So that's the first use case, the ability to build a model from scratch, do what-if scenarios, and forward engineer the whole thing to the database. Now I have a second
question.
Yeah, sure.
So this is great, right? So you basically, what you're showing me is, in the good old days when I was, working on Oracle databases, I used SQL Developer.
Were those good old days, Karthik? Those weren't good old days.
So not so good old days, yeah. So now, yes, I just want to make sure that I understood this right. So you are saying that I can basically do the entity relationship here, and in the push of a button, you are, again, it's schema-less. So you're basically creating some sample data and making the database and collections available for me so that I can go and run my queries and see if that kind of a model and matches my access pattern accurately in terms of performance and stuff. Is that the gist of it?
Exactly. So DocumentDB does not have the concept that you find in relational database. It's called a DDL, which is a create table script with a declaration of each attribute, the column data type, and all of that. So, but still, we wanted to help developers with the concept and be able to test out things without having to write code. And so we're doing a DDL by example, really is what we're doing here. And so it doesn't cost very much to do this. It's just a few clicks, test it out. If you don't like it, come back to the model, modify things, push it again, and do the work iteratively.
Great. So this is perfect, and you just showed, like, as a developer or an engineer, that you built this. But generally, we know, like, when customers choose a document database, they're either migrating from a legacy application, or they are building from ground up a modern application, and they have a bunch of people, a team of people that are working on it, right? So how can I collaborate on this with my team, right, instead of just one person doing it all?
Yeah, so actually, I mentioned that we have that our tool persists the
Yeah.
files in JSON, and we did that on purpose because JSON is text, and text is works very well as code with Git. And so we've decided to, instead of building our own proprietary repository and a completely proprietary way of checking in and checking out, we decided to use the most popular tool among developers, which is Git, whether it's through GitHub or Bitbucket or AWS code. It doesn't matter. It's Git technology. And so you have a remote repository that is cloned locally, and all collaboration, version control, peer reviews is done through the Git technology, and this enables a part of our strategy, which we call metadata as code, and it's just really wonderful technology that we're leveraging to have this powerful feature of collaboration and the version control that inevitably comes with the whole process of evolution and versioning of the schemas. Does that answer your question?
Yeah, no, it does. So basically, what I check in to Git is gonna be those schemas, right? That I create, and then the team can collaborate.
So actually, two things. Good question. There's models and there's schemas. We separate these two concepts. For us, a data model is a human understandable picture, an entity relationship diagram of how the data is structured. The schema is the consumable contract that is machine readable. And so the instructions, DB create collection with the sample JSON data that I showed earlier, that falls under the schema category, just as a JSON schema file, whereas the models or accolade models that get represented by an entity relationship diagram, both of them can go in Git. The models, so you can do the versioning of the model as it evolves, and then we create the schemas out of the model so they can be consumed by the technology.
Nice. Okay, that makes a lot of sense. So it's more like a logical model, physical model, even though we don't use those terms here, but it's
correct.
Kind of comparable. Okay.
Yeah, we stay away from those terms because
We
they have
do.
a lot of baggage.
Yeah, it came from those not so good old days. So sorry.
We're not judgmental. They were good old days at the time.
Yeah.
And they still have, their purpose today.
Absolutely, they do.
Right?
Yep.
So the second use case I wanted to talk about is the reverse engineering process. So I'm starting from a blank page again, and I'm going to go through reverse engineering of a DocumentDB collections. And in order to do that, I'm going to connect again using that same connect string. And so remember, if I go to Studio 3T, we have these databases, and each database has collections. The admin database we're not going to fetch because it's an admin database, and so there's nothing we should import from that. And you see that we have fetched the collections, the databases, and the different collections. In this particular case, and it includes, by the way, the one that we had forward engineered to the instance. I'm going to take this sample mflix sample database, 5 collections, and we're going to do a sampling of documents within that database, followed by an inference of the schema. Because again, as I said, there's no DDL, so we need to infer the schema from the sample. And we're also going to attempt to infer relationships that could be detected in the database, even though there's no foreign keys that are enforced or declared in the database. So we go through this process, which takes a few seconds because we need to fetch the documents, put them together, infer the schema, and we do this for each one of the collections.
What is the sample size?
The sample size is determined by a parameter here.
Oh, cool. That's configurable.
It's configurable, yeah.
Awesome.
And the other thing I didn't show is that you could also, in that dialog where I selected the database and collections, we could define a particular query also and a sort. So you can go very granular in what you retrieve back into the database. In particular, if you have multiple schema versions, you can do this in multiple steps by selecting one version at a time and bringing it into the tool, so you can compare the versions and show the evolution. So,
or like if my goal was to break apart a collection, for example, I could filter on just where I'd break it apart and say, this is what just these documents look like. That's awesome.
Correct. And this is just aggregation pipeline syntax that you type in or you paste in before you run the sampling.
Gotcha.
Okay, and so what we discover here is the 5 collections that were declared. Some of them are more complex than others. There's the movie collection where you see a whole bunch of nested structures. You also see that some fields have a star and others don't. What that means is we mark as a star and consider it and it may be a shortcut, but we consider them as required if we find them in 100% of the sampled documents. So we infer that if the field is present 100% of the time, it's probably something important that is deemed to be required. Others, as you can see, aren't marked with a star, and that means we found documents where the field was not present. So that's one thing we can see. There's something else I'm looking for. Yeah, here it is. We have here a field. So when we do the schema inference, we detect the data type from the data that is stored in the JSON. We can even go as far as detecting dates within a string if they're stored in ISO 8601 and things like that. But in this particular case, as you can see, and maybe I'm going to zoom in a little bit, it says multi. And if we go see the details here, we see that in some documents, we found a string. In some documents, street 2, that field name, had a null value. And on top of that, since it doesn't have a star, it wasn't found everywhere. So this is both the beauty of the flexibility of JSON and maybe possibly something that is an inconsistency in the way things are being programmed. That means some applications wrote the document without mentioning the street 2 field. Sometimes it was written empty with a null, and sometimes it was full of information. Now, in this particular case, it's probably legitimate, but the reverse engineering process may reveal some inconsistencies in the way things were developed. Another thing we see is that there was one relationship that was detected, and that's because we found here a field that had a data type object ID. And since it was not the key of that collection, we thought, well, it's probably a reference to another collection. And we fetched that value in all the different collections and found it in the movies collection. And so we were able to determine that there's a probable foreign key reference that is present in there. But at the same time, when we observe things over here, we see that if I look at the session ID, we have a field user underscore ID that probably is a foreign key reference to the user's collection, to the underscore ID field here. But we didn't detect it because it was stored as a string and not as an object ID. So again, this reveals a human will say, user ID, it must be a foreign key to the user's collection. We can't rely on field names because, who knows how it was spelled, what it meant, etc., etc. But the fact that it had no object ID made it that we didn't try to infer a relationship there. So once you have done the reverse engineering, you can do many things with this. You can enrich the model with descriptions and constraints. You can produce documentation in HTML, PDF, or Markdown to post on GitHub. You can also forward engineer or publish this to a data dictionary. And currently we have an integration with the Calibra platform, which is the leader in metadata management and data dictionaries. And so lots of things that can be done towards the business users who would want to understand this data model. Another thing that can be done is to compare this model that was reverse engineered from production, to compare it side by side with a baseline. So if I go briefly, I think I have a slide on this. Yes. So we have the ability to show side by side the nested structures and be able to identify additions, modifications, moves, and deletions in many different ways. And then we can merge this into a third model by picking and choosing which pieces of each model need to make it to the merged version, et cetera, et cetera. So for conflict resolution, for data governance, this is very useful. Any question on that? I still have 2 use cases to go through. So
this is really useful. I can see, customers that want to migrate, let's say from MongoDB or any other document database. It's fairly straightforward now, right? They can reverse engineer. They can get a good handle on how the data is set up. So this is good. But how do I evolve it from here, right? Like, let's say I have like some kind of a compliance requirement that I have to maintain certain standards. So how do I evolve it from here?
So basically, you would do what we call round-trip engineering, right? So if we want to insert an attribute here, you can do so, and then again go through the process of generating the script and forward engineering. I also want to mention that these properties here for attributes or collections or models in general, you can define your own. It is easy to do a configuration that adds controls, whether it's for PII or GDPR, or to create hooks that are going to be leveraged by your own scripts to generate code in any language. You can create custom properties that can be leveraged by your own tools. But you can evolve this schema. So one of the best practices is to do schema versioning. And schema versioning is very useful because it helps you migrate to a new structure, a new version of the structure, without taking the database down like we used to do in the past. There's no downtime. Right, we're in an era of instant gratification, and we don't want to have Sunday maintenance windows and things like that. So the evolution, the flexibility of the JSON lets you do schema evolutions. But this should be done with care, because if, let's say, every day you have a new schema version and you quickly end up with 20 versions of the schema, this creates inconsistencies in your data. And you don't want every application that consumes the data that you've stored to be maintaining different versions, because it would mean that you're spending needless CPU cycles, that if you have a reporting tool, that it needs to be aware of all these things, and there's a risk that users would do queries that give them partial results and potentially erroneous results as a result of the fact that they're assuming that all of the documents comply with a particular structure that they were expecting. So schema evolution is great for some time, and then you probably, and we see this as best practices with our customers, you want to do schema migration. And this can be done in a upfront, like we used to do with relational databases, but it can also be done in a lazy manner. If you read a document of an old schema version, you can write it back in the latest version, or it can be done at off-peak hours where you have predictive algorithms that will convert the data to the new version of the schema before it's going to be needed, until you have migrated all of the documents in your database. So there are strategies for schema migration that should follow schema evolution, and we see that as a big trend in best practices when working with document databases.
Awesome. Thanks for that explanation. Yeah, makes a lot of sense. Schema versioning, I've done it myself multiple times. It's super helpful. Thanks for calling that out.
All right. We have another use case, which is if we reverse engineer from a DDL and we support reverse engineering from all kinds of different DDL dialects, let's say. I've imported here the Northwind database, very famous. And as you can see, we have nice, flat, normalized tables. And we're going to go through a quick denormalization exercise. Now, we're doing this manually, knowing what it is that we want to do in order to support the access patterns of the application. We're not doing this automatically by and theoretically by analyzing Oracle logs or anything like that, which lead to undesirable results. So a human who knows what they're doing can do this process, and we facilitate the process. You see here the orders table and the order details table. And with the document database, you're going to want to combine this. So by just a few clicks, we're going to combine order and order details table as an array in the parent. We know that this is what we're going to do. There's another type of embedding that can be done, subdocument in the child. We'll see it in a second, but we choose here to do an array in the parent, and we click here, and we can now delete the order details table, and we have now embedded an array of sub-objects that are made of the order details table. And we're going to go one step further. We're going to create a foreign key to the product ID, and we're going to go the next step, suggest denormalization, and we're going to do it this time, orders and products, as a subdocument in the child. But this time, we have a query pattern for the product maintenance, so we're not going to delete the product table. There are a few fields that are unnecessary here, so we're going to remove them. And you see how we've created an orders collection, which is made of an array of order details, order detail lines, which has also embedded some product information. And if we go to the MongoDB script tab, it's going to create the document, the sample document, and the DB collection creation script. Of course, we would have to add the indexes and things like that. But you see, we've quickly created this denormalized structure from an Oracle DDL, and we can go through that process, of course, on a much bigger, more complex database.
That's awesome. So in this case, you chose order and product, right? When you did the subdocument.
Mm-hmm.
But then how did it know to be at the order detail level? Because each order detail is going to have the product ID or the SKU.
Oh, it knew that because of the foreign key relationship that I drew from the product ID that was in the order details table to the products table. So that's how I knew
it's
that.
Smart in terms of recognizing that relationship and adding it at appropriate nested level then.
Yeah, exactly. So last use case I wanted to go through was the ability to create a model-driven REST API. So basically, from this model, you can forward engineer to an API model in either Swagger or OpenAPI. I've done it so it generates for each entity based on a template that is user customizable, the request and responses, and generates the OpenAPI file syntactically correct that can be copied and pasted into Swagger Hub or whatever other tool you have, with all of the metadata and things that are needed to so the entities were created for each one of the collections with their schema, and the requests and responses were created based on the template configuration. So that's another tool that helps with governance, with consistency, with quality. And every time you evolve your schema of the underlying model here, the REST API can evolve in sync with whatever evolution you will have made in your model.
And is
So
that automatic, Pascal? Will the REST API
so
evolve?
automatic in the sense that the sync button needs to be clicked, or you need to open the OpenAPI model, and it will retrieve from the underlying model and update automatically, or after letting the user know that there are differences, and the user confirms that the changes are desired.
Very cool.
So that wraps up the demo of the tool. So very basic use cases, very simple to learn very quickly how to use the tool in an intuitive manner. But as you grow, there's lots of bells and whistles that add complexity, but the tool menus are very simple. This is not a bloated software with lots of features. There's basic use cases that we support with lots of permutations within these use cases to satisfy the needs of people in the trenches. That's what we try to be helpful for to the developers, the data architects, the data modelers.
Not the data amateurs. I like it. The guys in the trenches. This is good.
Yeah. So Pascal, this is fantastic, right? Again, this is a problem that is pretty evident. So can you talk to us a little bit about who your competitors are? Who does this? Who else does this?
So our number one competition are people who think that data modeling is not necessary to do their project successfully. And again, it's possible if you're just doing a small application with an IoT device with just a handful of data points. You obviously have the schema in your head and you don't need a tool. But if you're a Fortune 500 company, a government agency, any kind of organization with complex application, you're going to need a tool. We got our inspiration from traditional tools that have been around for decades. I named them earlier, but really none of these tools were built for nested structures and polymorphism and the hierarchical structure of JSON. And we built the tool from the ground up because there was a complete void in the market. Frankly, there is no tool in the market today that does this kind of stuff for a couple of these databases, let alone for all of these technologies of data at rest or data in motion.
That's very interesting, right? It's such a common problem, and there's no other solution. Kudos to you guys for thinking through this and helping the developers to think through the document model.
Thanks, but I actually give credit to our customers, our early adopters, and every new customer we get, because all of these new ideas, all of these needs for new platforms like DocumentDB, all of this need comes from our customers.
Yeah, customers do drive requirements. I see a common behavior pattern there with Accolade and AWS, right? We also are most of our requirements are driven by customers. So absolutely spot on there. No, we are coming up on time, but Pascal, this was a terrific session. I mean, I certainly learned a lot. I'm sure Cody learned a great deal as well.
Yeah, this is, data. Yeah, just briefly, I know that we talked about this before the show, but data modeling for NoSQL, you have to. It's essential. It's part of it, and this tool just makes it. It's a no-brainer. Using your tool just makes it so easy to keep track of it and keep up to date. And I can't wait. I'm about to get deep in this software.
Yeah,
cool.
Yeah, I'm ready to jump in as well. So again, thanks so much, Pascal, for getting on our show and explaining this to our audience, and more importantly, announcing the release of Accolade support for DocumentDB. So thank you, and kudos to you and your team. Look forward to working more with you and our customers that are common, that need this tool and the capabilities that you offer. Thanks a lot.
Thank you for having us on the show. Very exciting.
Thank you.
Okay.
Take
Bye-bye.
care, guys. Stay safe. Happy New Year and Merry Christmas to everyone out there.
Yeah. Same to you.
Bye-bye.
All right. Bye-bye.